Hello. You should be able to see me and hear me. Right. Okay, so today we're finalizing assignment 2, and I've got some questions on trigonometry and some questions on kinematics. So let's get to it. Right. So kinematics and trigonometry. So the first one, so we'll do 2 questions on trigonometry, and then we switch to kinematics. All right. Can everyone hear me well? Type something in the chat if you can. Okay, perfect. Right. So the first problem is to solve an equation, and just a second. That's weird. Okay, right. So we need to solve the equation, and this is a product of 2 things. So we know that if you have a multiplication and it's equal to 0, then one of them is 0. So basically, we can say that this means that 1 minus sine x is equal to 0, or tan squared x minus 3 is equal to 0. And so from here we can write that, okay, that means sine x is equal to 1. Let's solve sine x equal to 1. Well, we know that sine x is equal to 1. If you draw this circle, x and y, so sine is 1 here at 90 degrees. 90 degrees, or, well, let's do it in radians. So x is pi over 2. But it's not just pi over 2. It's any value, indeed. In fact, pi over 2 plus 2 pi n, where n is an integer. Okay. Does that make sense? Is there anyone here who doesn't understand why this is true? Is there anyone confused? Okay. And now we look at this one. So this is tan squared x equals to 3. So tan x equal to plus or minus square root of 3. Right, so we have all right, sorry. I'm back. Apologies, some just tutorials have started for some groups, and just things need sorting out. Right, so so no one said that they don't understand why this is. So that is fine. What? Not math last time. We did physics last week after the launch webinar. Yes, we did physics. We're doing physics and maths today. So tan x is equal to root 3, and yeah, so x and y. So where is it equal to square root of 3? Well, we know tan is square root of 3 when it is pi over 3. Also, and minus square root of 3 when it's minus pi over 3. Minus pi over 3. But also, we know that tan is over here. So half a turn later, because the period of tan is pi. And therefore, this is pi over 3, this is pi over 3 plus pi. And then again, another half turn later, you arrive here. So you could say x is equal to pi over 3 plus pi n. With not 2 pi n, but pi n, because it's half a turn, then another half turn, etc. Where n is a whole an integer, but it also minus pi over 3 plus. So you can simply put plus minus pi over 3. I don't understand how we got the first value of x, like pi over 3. You just need to know it. It's from the table. Yeah, so there are standard angles. You need to know that sine, cos, and tan of the standard angles of okay. This is the optional webinar. This is the webinar you don't have to attend. Your tutorials, we do expect, yes, are sort of compulsory. Well, 75%. So yeah, this is a webinar. This is just me talking. I'm a talking head today, and your webinars are at a different time. Okay, so you have 0 degrees, you have pi on 6, you have pi over 4, you have pi over 3, and you have pi over 2. And you need to know these, and you kind of need to learn them by heart. Sine 0 is 0. This is 1/2. This is square root of 2 over 2. This is square root of 3 over 2. This is 1. And cos is the same thing, but the opposite direction. Square root of 3 over 2. Square root of 2 over 2. 1/2 and 0. And tangent is just sine over cos. So this is 0. This is 1 over square root 3. This is 1. This is square root 3. And this is this doesn't exist, undefined. So what do you see? You see, oh, okay. So this is square root of 3. So that is here. So this is pi over 3. That's how I know. So I know that arctan. How do we know when the webinar starts? We will email you. So about half the webinars are starting this week and half of them are starting next week. So if you haven't received an email, you start next week. Yes, there is a trick, Neil. Thank you. That is a very good one. You write 1, 2, 3, 4. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Divide by 2. And then you take the square root. Square root, square root, square root. And that gives you the same thing as here. So this is the same thing as this. Okay. Right. So yeah, and there's no and that's it seems that you have to. It seems like it's done, right? So the problem seems very straightforward. X this and X is this. However, you probably haven't noticed. You probably haven't noticed, but some of these answers are not valid. Can somebody tell me which answers are not valid? Oh, they is it true or is it a coincidence? Oh, well, is it a rule or is it a coincidence? I tend to think it's a coincidence, but because we've chosen them. We've chosen the values pretty randomly. I mean, we've chosen the angles that give us. Okay, it's not random in the way that we've chosen the angles, because 30, 45, 60, and 90 are not chosen randomly. They're chosen because of that pattern. So we don't choose the sides, we choose the angles that correspond to that pattern, because that's the simplest pattern you can get. That's yeah. Okay, so pi over 2. Ooh, Archie, very good. The value x over 2, pi x over 2, is not valid because tan pi over 2 does not exist, remember? Tan pi over 2. So x over 2, pi over 2 is not a valid answer. Not valid. Valid. Because if you plug in the pi over 2 here, this expression will be undefined. Undefined. So this is undefined. Undefined when x is pi over 2. Right, so the only possible answer is x is plus minus pi on over 3 plus pi n, where n is an integer. And this way we are covering all the values. Problem 2. Sine 2x is equal to cos to the power 4x. Zero times undefined is not 0. No. Because 0 multiplied by undefined is not 0. I'll show you why. It's a very good reason why. So let's say we have x squared multiplied by 1 over x. And x, let's say x tends to 0. X is 0. So this is 0. And this is undefined. Undefined. And if you simplify the expression, it becomes 0 squared divided by 0, which tends to 0. Tends to 0. But no, okay. It's x squared over x, which tends to 0. So this is infinitely small. And at 0, it's still undefined. Like 0 times undefined is undefined. If x is 0 and you have x multiplied by 1 over x squared, this expression is infinitely large, so it's 1 over x. It's 1 over x, so it tends to infinity. So this is 0, this is undefined, and when you multiply them, you get infinity. 0 times undefined, you get 0. And also, you could get x, okay, x tends to 0. X tends to 0. X multiplied by 1 over x. So this is x, so 0 times undefined, which is 1, tends to 1. So 0 times undefined can literally be anything. That's why it's undefined. Archie, x over x squared over x is the same as y equals x, except it doesn't exist when x is 0. If you draw the graph, of y equals x squared over x, it doesn't exist when x is 0. So you put a dot here. But otherwise, it is the same graph. You just draw this. It has an it has a discontinuity of the first type. The function is discontinuous at x equals 0. Okay, right. So yeah, that is a good question. Undefined is undefined for a reason, and anything times undefined is also undefined. You could use L'Hopital's rule, yes, but to evaluate the limit, not x squared over x. X squared over x doesn't exist. The limit does exist. Look, if you do the limit as x tends to 0 of x squared over x is 0, but x squared over x is undefined if x equals 0. And Neil, if you had the function x plus 1, x plus 2 divided by x plus 1, this would be the same as x plus 2 with a discontinuity, yes. And we can show you that. That's a Desmos thing. You have y equals, let's make it simple, x multiplied by x minus 2 divided by x minus 2. Okay, so you can see that it's pretty much the same as the y equals x graph, except if you scroll to this one, it says undefined. Okay. Okay, problem 2. You have sine 2x is equal to cos. Sine 2x is equal to cos 4x over 2 minus sine 4x over 2. So in most equations, which are not like basic, you need to do something to it. Can't just cancel because you have to consider the original equation, plug into the original, it would be undefined exactly. Thank you. Thank you for the answer. Yeah, absolutely. So sine 2x is equal to cos. So I'm going to factor this because I'm going to, this is a difference of two squares, right? So a to the power 4 minus b to the power 4 is a difference of two squares. So it's a squared minus b squared multiplied by a squared plus b squared. So this can be written as cos squared x on 2 minus sine squared x on 2 multiplied by cos squared x over 2 plus sine squared x over 2. I don't know why I put the brackets. This is very familiar to you. This is 1 because it's the main trigonometric identity. And this is cos squared minus sine squared. Cos squared minus sine squared. Somebody remind me, what is it? Cos 2x, thank you. Cos 2x is cos squared x minus sine squared x. So here we have sine 2x equal, then this is cos double of that angle. So this is cos double x over 2, which is the same as cos x. Now, sine 2x is equal to cos x. We need to make it simpler. To do that, we simplify sine 2x. You get 2 sine x cos x equals cos x. Now, a student who is new to COMPOS might think you just cancel the cos x. Why can't you just cancel the cos x? Because it might be 0. Yes. You can't divide by something. You want to divide by cos x, but before you do that, you have to make sure that it is not 0. So there are two options here. You can say, let's take everything to the left-hand side and factorize. So that's option 1. So you get 2 sine x cos x minus cos x is 0. Cos x, open bracket, 2 sine x minus 1 equals 0. And then you have two options. Either cos x equals 0 or 2 sine x minus 1 equals 0. And then you solve it. So cos x is 0. So if you draw the circle, cos x is equal to 0 is here and here. So this is pi over 2. And this is pi over 2 plus pi. So it's pi over 2 plus pi k, where k is an integer. This is sine x equals a half. So x is equal to. All right. And this. Okay. So we have x. Well, sine is equal to x. I've done this last time. I went through this one. So you have, and you have. This is x is pi over 2, so this is 1. Oh, resume share. Okay. Yes, thank you for posting the whiteboard. So you have sine x is 1/2. So you have two different points where it's 1/2. Because if you draw the line, because that's the point where the y coordinate is 1/2, right? Because sine is the y-coordinate, and the y-coordinate is 1/2 is at 2 different points. And these 2 different points are pi over 6 and 5 pi over 6. Pi over 6. And there's a very clever way of writing this down. We write -1 to the power of n multiplied by pi over 6 plus pi k, where k is an integer. Okay. And apologies for the notifications. I don't know how to switch them off. Notifications. Oh, here it is. Okay, so we have this. This is a different way of writing it. It's actually a clever way of doing it. So you have -1 to the power n, pi over 6 plus pi, pi to the power k, of course. And if you don't understand how this works, try substituting k equals 0, k equals 1, k equals 2, etc. So if k equals 0, this is 0. This is 1 times pi over 6, and it's going to be pi over 6. If k is 1, it's going to be 5 pi over 6. If k is 2, that's going to be 13 pi over 6, etc. So just check this out. It's quite an ingenious way of writing. I really like it. Okay, so and these are the answers. Okay, so these are the possibilities. Right, any questions on maths? Do we need both an N and K? We don't. It's up to you. I just used K here, and I used N here. As long as there's no conflict between them, it's fine, right? For the first answer, I used N, and here I use K, where K is any integer. You could say this is N. Like it probably would be better if you write N, just to show that these are unrelated, that this K and this K are unrelated. But they could be related. Why not? They take any value. There's no difference. Okay. Any questions on math? For anything solving cos, could you write solutions x angle plus pi? No, for cos, if you have cos, the general solution for cos theta equals a, theta is plus minus arc cos a plus 2 pi n. This is the general solution for, and n is the whole number. Well, of course, a has to be between -1 and 1. For sine theta equals a, theta is -1 to the power n arc sine a plus pi n, where n is a whole number. And for tangent theta equals a, theta is arctan, it's the simplest one, arctan a plus pi n, where n is a whole number. So yeah, just explore these in detail, because I think it's great fun looking at those and just saying, oh, there's 2 pi n, there's pi n. Well, this is pi n because it's understandable, that because the period of tan is pi n. What this is pi n for a different reason. So yeah, that's quite interesting. Okay, and I don't know how to do problem 9 in the maths assignment. Problem 9 in the maths assignment. Let's have a look. It's 1202. Okay. Now let's take an example. Sine 331. Okay. You need to express it in terms of trigonometric function of a single argument in the range 0 to 45. Well, sine 331. So let's first try to locate 331. Where is sine 331? Well, 331 is somewhere here. 331 degrees. So this is 270. Oh no, 331 is not here. 331 is here. That makes life slightly easier. 331 is here. So 331 is actually 360 minus 29. It's equal to sine 360 minus 29. And you can use the rule of the formula. It's going to be sine 360 cos 29 minus cos 360 sine 29. Sine 360 is 0, so that's 0. So that's going to be equal to minus, this is going to be cos 360, that's 1. So it's minus 1 multiplied by sine 29, so equal to minus sine 29. And that's the answer. Does that make sense? Mena, does that make sense? Okay. So yeah, the answer should be in terms of a single angle, which is between 0 and 45. Is there any source you could follow trig identities we should know? The ones that you should know. Well, any A-level sheet is sufficient, I'd say. You can go more. You can just go to the there is a web page. There's a Wikipedia page on there's a Wikipedia page on all the identities that you could think of. It's immense. It's absolutely massive. But yeah, like the double angles, half angles, pretty much all the the identities that are in our assignment is more than enough that you need probably in your life for trigonometry. So we've tried to be very, very thorough. Okay. Neil, what is the question? Co-function. Could you do sine 2x equals sine pi over 2 minus x using equal to each other? Could you not do sine x equals sine pi over 2 minus x? Right. Okay, Neil, I see your question. I'll copy that, and that's an important question. This is a fundamental question. Okay. Sorry for pointing this out. If you're uncomfortable, I can delete that. Could you do sine 2x equals sine pi over 2 and then set them equal to each other? Well, yes, you could. The problem is that if sine A equals sine B, then A does not equal to B. It doesn't necessarily equal to B. It does not mean. So not then, I'd say that it does not follow that A is equal to B. So it does not follow that A is equal to B. Let's put it this way. It does not follow that A is equal to B. Does not mean. And a very simple example. Sine 30 is equal to sine 390. But 30 is not 390. Therefore, the way that you're suggesting that sine 2x is equal to sine pi over 2 minus x does not mean that 2x is equal to pi over 2 minus x. There's just one solution, yes, but not. This only works for one-to-one functions. This only works for one-to-one functions. For example, if arcsine A equal arcsine B, then A equals B, necessarily. So it works for arcsine because arcsine is a one-to-one function. Because arcsine is a one-to-one function. For anything involving cause, Simon, you can explain it. Okay. Or there is. Can someone copy the question? Yes, thanks. Does the trig function have to be the same as the one we started with? No. It's just a trigonometric function of a single angle. Can you explain the last part again? Oh, which part? Sorry, I'm lost. There's been many last parts. Hyperbolic trigonometry later in the course. Somewhat, not too much though. We don't have a separate assignment on hyperbolic. Just yeah. Why would you apply this? How would you apply this technique to cot? Cot is, oh yes, you can use that. Oh yeah, of course. If you're using this technique, so for example, you need I don't know, tan. You need to express tan 67 is the same as cotangent. Oh, sorry, is the same is equal to tan 90 minus 23, which is the same as cotan 23. You can use that, of course. You don't have to. You don't have to use this method. You can, but yeah, you don't have to. By all means. Yes, I get that, but would give you one solution to then manipulate. It would give you one solution. No. I'm not sure. I'm not 100% sure what you mean. Okay, so we've got some more exciting. Yes, cos x equals sine 9t minus x is an identity. That is true. Yes, but that wasn't the question. We were talking about this. We're talking about this equation. So here, it was suggested that instead of cos, we write sine. So sine 2x is equal to sine pi over 2 minus x. Okay. And then drop the signs. Well, you can't do that. No, so as I've demonstrated before, you can write it down, but you can't drop them. So the only reasonable way is the one I did. No, there's another way. If you you can divide by cos x. You say, what if cos x equals 0? Then calculate the consequence of that. If you and then you say, what if it's not 0? And then you calculate the consequence of that, because then you can divide. All right, let's switch to physics, because I really have some amazing questions for you, and I really want to do them. So question 4, this is about, I don't know if you've noticed, but the biggest point I was trying to make with your assignment 2 is for you to learn what an equation of motion is and how to use equations of motion. Okay, so an equation of motion shows you the position at any given moment of time. Okay, so we have a ladder, and we start the ladder in upright position, and the ladder moves such that the bottom point, the point A, moves at a constant velocity. At a constant velocity. Oh no, sorry. Let's not. No, let's do it properly. I'll modify the question slightly. It's not. In the position shown. An equation of motion with the ends of the ladder. And okay, so it starts from x0. So x0 is the initial position of the bottom of the ladder. Okay, I've modified the question slightly, ever so slightly, but that's yeah. So this is where it is now. It is initially, and it moves from here with a constant velocity. So equation of motion of point A. point A. So x, A, the position, x position of point A is equal to the initial position, where it is now, plus the velocity multiplied by t. Okay, velocity multiplied by t. So that's very straightforward. So why is this an equation of motion? Because it gives you the position of A at any given moment in time. You give it a time, and it gives you the position. So this is an equation of motion. Tick. All right, for point B. Equation of motion of point B. Well, so initially, it is at this point, y0, and then it moves down. Now, we need to be very careful of what we know and what we don't know. We don't know the initial position, and we don't know the initial velocity of point B. So we can't really use any known equation. So, well, let's say that this is y, and let's find a link between y and this is x. This is xa, of course, because this is the origin. This is xa, this is y. So using Pythagoras, we have xa squared plus y squared is equal to L squared. So we can express y squared is equal to L squared minus xa squared. And we can find the square root. So y is equal to plus or minus square root of L squared minus xa squared. And of course, y is positive because the end B cannot fall through the floor. It's going to be positive. So y of t, y position of point B, is the square root of L squared minus, and now we know the formula for x0, so x0 plus vt squared, and that is the equation of point B, equation of motion. So it contains known parameters such as L is the length of the rope, x0 is the initial position, v is the velocity, we know velocity, and t. So it's a function of t, function of time. So the equation of motion should be equation, would you do this? Yeah, Pythagoras rule, absolutely. But note xb, it's y, because xb is 0. xb is 0. And ya is also 0. So you could write down the equation. You can write down the equation in even fancy way. You can write r a as a function of time. The equation of motion is a vector, so it is x0 0. Well, let's not get carried away, plus vt 0. And rb, the position of point B of t, is equal to 0 and square root of L squared minus x0 plus vt squared. And if you really want to, if you really A and B signify the ends of the ladder, yes. If you really want to be clever with this question, you would also limit the time, because the model doesn't work forever. It only works for a short period of time while the end is moving. Point B meets the floor when XA is equal to L. So let's substitute that in. So L is equal to x0 plus Vt. So T is equal to L minus x0 divided by V. This is the maximum time. So time is greater or equal 0, less than or equal what's it? L minus x0 over V. Because we don't know, well, we can roughly predict what's going to happen next, but the model doesn't work beyond this range. So you can, this is like the cherry on the top, right? Wouldn't the y component of R be negative since the ladder is moving downwards? The y component will not be negative because y is positive, but the velocity would be negative, yes. But they're not asking about the velocity. If we want the velocity, let's check the velocity of y. So velocity of end B is the derivative of, with respect to time, it's the derivative of this. So it's derivative of 0 square root L squared minus x0 plus Vt. We are going to do derivatives next week. Yeah, so the next topic, next assignment is derivatives. That's 0. And if you find the derivative of that, that's going to be minus 2 x0 plus Vt multiplied by V multiplied by 1/2. It's a very complicated chain rule. 1/2 multiplied by 1 divided by 2 square root L squared minus x0 plus Vt squared. And when you simplify that, you will see that it is negative. This is not an assignment question, Archie. This is, I'm just showing you that somebody asked that isn't y negative? No, y is positive, but velocity is negative. And you can see that the velocity is negative. Yeah, so yb is greater than 0, but velocity of b is negative. And I've just shown that it is negative by using a very complicated chain rule, but yeah. You'll do these sorts of questions in the next maths assignment, so don't worry. I won't stop showing you how I did it. It's just not the topic that I wanted to show. Problem 5. A passenger. I'm pretty sure I miss. How do you spell passenger? That's embarrassing. Passenger. Oh, people train. Passenger. Okay, thank you. Passenger. In French is passager. So it's A, and in most languages it is an A. Anyways, traveling on the same so they're traveling on parallel tracks. So we have a short passenger train and we have a longer freight train, and the passenger train is moving faster. It's moving with a velocity of 102.6 kilometers per hour, and this one is moving at a speed of 48.6 kilometers per hour. 2 is 48.6 per hour. Wouldn't you need to know the position of the train relative to the freight train to solve this? Well, no, it says how long will it take to overtake, assuming we count the time from the moment the front of the passenger train meets the back of the freight train. So at t equals 0, it's this. This is position at t equals 0, and then at position. Now, I'll show you something that I don't really like when people do, but it makes life so much easier. So at position, this is when the passenger train completely overtakes, and that's t equals, and this is the bit I don't like what physicists typically do. They say t equals t. Oh, it's the time. You could say t equals tau. That would make more sense because you can't use the same letter, because t equals t, duh, t is always equal to t. But I use it because it's so convenient. But technically, you need to say it's t equals t1. That would be a strict better way of saying. And okay, let's stick to t equals 0 and t equals t1. And well, it might seem sophisticated, but actually it's not. You just need the relative velocity. The relative velocity of the trains. So relative velocity. So you need to assume that the freight train is stationary. Relative velocity is v2, v1 minus v2, v1 minus v2, and that is 102.6 minus 48.6, and that gives us 102 minus 48. 102 minus 48, 54 kilometers per hour, which incidentally is 0.6, is 15 meters per second. 15 meters per second. So we can for an observer in the freight train, as far as the freight train driver is concerned, he is stationary. He or she is stationary. As far as the freight train driver is concerned, he or she is stationary, right, and the passenger train is traveling at 15 meters per second. And the distance that needs to be traveled is equal to the sum. The distance that needs to be traveled is L1 plus L2. So it's the time, or T1. T1 is equal to L1 plus L2. It's the sum of the distances divided by the relative velocity. So V1 minus V2. Then that gives us 120 plus 630 divided by 15 meters per second. What is that? 750 divided by 15. What's that? 50 seconds? 50 seconds. Okay, that's great. That's pretty much it. And no, it's not 50. Yes, because you need to travel. And a convenient way of thinking about it, the freight train is stationary, and the passenger train needs to travel this distance. This is the distance traveled by the passenger train, which is L1 plus L2. So in the previous question, why would I equals x0 plus vt? X0 is the position when it's right next to the wall. Sorry, not next to the wall. No, x0 is the position at time equals 0. So we start from this position. Sorry, I wasn't didn't clarify. At t0, it is in the position shown. So that's the initial position of the ladder. So there's a question about the equation. So it's this because when t is 0, x is x0. Problem 6. Object is launched at an angle alpha with initial velocity v0. At what time the velocity is going to be 45 degrees to the horizontal? So, okay, so we assume we launch something from a very tall building. So we're not limited. There's no bottom. And we throw something. We throw something at an angle of alpha. And the thing is, we don't know alpha. And we throw it at an angle alpha. And velocity v0. Okay. Immediately, we can think of one of the Suvat equations, and this is a very useful one. So Vx is going to be constant. It doesn't change. And that's equal to V0 cos alpha. That's fine. That's, yeah, V0 cos alpha. But Vy, that is going to change. And the Suvat equation that is very useful here is V is equal to U plus AT. So Vy is going to be V0 sine alpha, that's the initial velocity, minus GT. Okay. Now, it's 45 degrees. The angle is 45 degrees. So at some point, so it's traveling like this. So at some point, the velocity is at 45 degrees to the horizontal, and or it is like this. So at some point, this is 45, or this is 45. At this position, because you have the horizontal velocity and the vertical velocity, let's write t, because this is also an equation of motion, Vx of t. At this position, Vx is equal to Vy. So when it's plus 45 degrees, let's call it plus 45 degrees, and Vx is equal to Vy. So V0 cos alpha is equal to V0 sine alpha minus GT. Okay, so GT is equal to V0 sine alpha minus cos alpha. So T is equal to V0 sine alpha minus cos alpha divided by G. Okay. Normally you can assume 10 for G. So unless we specifically ask you to use 9.8, use 10, because it just makes calculations easier. And we'd rather you use the calculator less. And yeah. And using G is 10 usually allows you to do calculations without a calculator. But here you don't even need the value. So that's the T. Now, and you can see that if alpha is less than 45 degrees, then T is going to be negative. And T is going to be negative. So it doesn't make any sense. So if you launch at an angle alpha, which is less than 45 degrees, it will never be 45 because you launched it at a smaller angle. So it's never going to be plus 45. And now minus 45 degrees. Now in this case, the horizontal velocity is Vx and the downwards velocity is Vy. So Vy is minus Vx. They have equal, the components are equal, but one is down, one is up. And you can say, okay, so that is Vy, which is V0 sine alpha minus GT equal to minus V0 cos alpha. So GT is equal to V0 sine alpha plus V0 cos alpha divided by G. And that's it. So effectively, you could say the answer is, well, there are two cases here. So you can say V0 sine alpha plus minus cos alpha, because they're only different by G. That's quite an interesting expression, by the way. And that is if alpha is greater than 45, and greater or equal than 45, but it's equal to V0 sine alpha plus cos alpha divided by G. And this is only if alpha is less than 45 degrees. So either way, this is the answer. Okay, fair enough. Yes. Yes, thank you. It's not a dumb question. This is a you caught me out. You caught me out. Minus 45. It's less than or equal. It's greater or equal minus 45. And yeah, you've considered a case which I haven't considered. So yes. Thank you. Right, problem 7. What is the minimum velocity? Kind of a vague question, but I hope you understand. So minimum velocity, so that the motorcyclist lands safely, doesn't fall into the ditch. Okay, so we are, how to do this? Well, I would say draw a coordinate axis. Always start with drawing coordinate axes. This is X and this is Y. So you want to end up at this point, and you have the initial velocity. Velocity V, let's call it V0. Angle alpha. So we start with the X position, X of t, the X position. So the initial coordinate is 0 plus initial velocity. Well, I'm just going to say the formula that I'm going to use. X equals x0 plus v0t plus 1/2 at squared. So very helpful. This is a modified Suvat equation, if you remember from the previous webinar. If you're not, just watch the webinar. Watch the previous webinars. So x of t is x0, that is 0, because we start from 0, plus v0, so v0 cos alpha multiplied by t, plus 0, because the acceleration is 0. Okay, so that is v0 cos alpha t. Yt, the y coordinate, so we started with y0, and y0 is h plus v0 sine alpha t minus 1/2 gt squared. And we know that the final position, final position is a y equals 0. Therefore, we can find time. So h plus v0 sine alpha t minus 1/2 gt squared equals 0. We can multiply it by 2, multiply by minus 2, multiply by minus 2. So it's gt squared minus 2v0 sine alpha t minus 2h equals 0. What can we do here? Well, we can solve for t. We can solve for t. Maybe not ideal. So let's stick a pin in that. It is a quadratic. Yes, I really don't want to do the quadratic. Like honestly, I'm not thrilled about the idea. So before doing the quadratic, can I make my life easier by looking at this? Well, we know that when final position is x equals s. All right, so we can say that from here I can get s is equal to v0 cos alpha t. So t is s divided by v0 cos alpha. That doesn't help, honestly. But okay, let's do the quadratic first. So from here, I've done the quadratic. So t is equal to minus b plus minus square root of b squared minus 4ac. Yeah, the good old-fashioned formula 2a. So minus b, so 2v0 sine alpha plus or minus square root of b squared 4v0 squared sine squared alpha minus 4, so plus 8hg divided by 2g. Now, plus or minus, of course, we are interested in the plus, because if you look at it, this expression is greater than 2v0 sine alpha. So basically, if you put a minus here, this is going to be negative. The time is going to be negative, so it doesn't make sense. So it only makes sense when plus. So it is 2v0 sine alpha plus square root of 4v0 squared sine squared alpha plus hg divided by 2g. And that's the time. That's the time of landing. And if it's that the time of landing, we have s divided by v0 cos alpha is equal to 2v0 sine alpha plus, I think I've made it worse, 4v0 squared sine squared alpha plus 8hg and divided by 2g. Because what I've done, now you need to solve for v0. Yeah, doesn't look good, does it? Okay, so from here, solve for v0. I don't want to spend. Don't want to spend 15 minutes doing that. So maybe you can find a better way. I think the better way would be to just plug in t from here, and then you get a quadratic in terms of v0, and that makes life easier. So what you would do here? You take this and you plug it into here, and then you get a quadratic in terms of v0. So from here, get a quadratic. Take in v0 and then solve for v0. I think that's the way forward. Yeah, I went the wrong way. I don't want to waste time doing it over again. Okay, so let's have a look. I don't think so. Why would you get a cubic? With a t squared? Yeah, but you're going to get g of s over v0 cos alpha squared minus 2 v0 sine alpha multiplied by s divided by v0 sine alpha. 2h equals 0. Okay, it's a super easy quadratic. So you got this cancels and you get 2s minus 2h. So s over v0 cos alpha squared is equal to 2s plus 2h divided by g. So v0 cos alpha equals s multiplied by square root of g divided by 2s plus h. So, and that means that v0 is equal to s divided by cos alpha, square root of g divided by 2s plus h. Okay, that's way easier. That's the answer. You see, sometimes you just go the wrong way. Of course, if you simplify that, that will work out the same. Why did you use cos A for t and g sine A for t at v0? What do you mean? I'm not sure. I'm not sure what you mean. Use cos A for t for g. I'm not sure. I'm not sure what you're asking. Right, problem 8. What would you do in here? You have a ball falling from 1 meter and it bounces elastically from the surface and then falls back onto the surface. And what you need is you need to find because t is s divided by v0. Oh, okay. Yes, you are correct. Yeah. No. Okay, I'm not. I'm very sorry. This is just embarrassing. This is what happens when you don't write properly. This is cos alpha, or v0 still cancels, and this is tan. I wondered, it doesn't make any sense that this is 2 tan 2s tan alpha, 2s tan alpha, 2s tan alpha, 2s tan alpha plus h. Okay, that makes more sense. Thank you. Thank you. Right, this one. Well, I've done a very similar one. So what you need to do is you need to find the initial velocity. We are falling from 1 meter. I'm going to use the conservation of energy here. So it's going to be mgh is equal to 1/2 mv squared. So 2gh is equal to v, square root of 2gh. So the velocity is going to be square root of 2 times 10 times 1. So that's going to be, this is going to be square root of 20. What's square root of 20? Square root of 20 is 2 square root of 20. 4.4 4.47 meters per second. That's the initial velocity. That's the velocity when it hits the surface, and then it bounces off that surface with a velocity of 4.47 meters per second. Now the angle, well, this is 30 degrees, so this is 30 degrees, 30 degrees, so this is 30 degrees. So this also must be 30 no, sorry, that must be 60 degrees. 60 degrees. And then you draw the coordinate axes. Very importantly, you draw the coordinate axes like this, x, and like this, the y is perpendicular. And then you just redraw the whole thing like this. The y-axis, the x-axis, the y-axis, and then you have the launching at an angle of 60 degrees. And you need to know where it lands. However, you need to take into account that the acceleration is like this. Acceleration is downwards. So acceleration in this case is going to be this way because you're going down slope. So you're accelerating down as well as up. So you have the acceleration. So acceleration in the x direction is going to be g sine 30 degrees, and AY is g cos 30 degrees. And the equation of motion, this is going to be V0. So you have the position of the mass with respect to time is the initial position, which is 0, 0, plus the initial velocity, which is 4.47 cos 60, 4.47 sine 60, minus 1/2 t square, times t, sorry, minus 1/2 t multiplied by g sine 30, g cos 30. And then you sub y equals 0 to find time. That's it. But the yes, angle of incidence equals angle of reflection. So it bounces up. So do explore this, and then you just write the standard equation. Once you've done the standard, once you've written the equation, everything else just falls into place. Okay, so I'll leave you to it. Enjoy the rest, and we're still sorting out the groups. So if you haven't received your group details, do have a t squared. Yes, it is meant to be t squared, of course. So RT is R0 plus V0t plus 1/2 AT squared. This is the equation of motion. This is a Suvat. This is the hyper-Suvat equation. All right, have to go. See you all. When doing A, why did you use 30? Well, if you look at the diagram, because it's the acceleration along the slope. This is G. This is G, and G has a component perpendicular to the slope, and G has a component parallel to the slope, and it works out that this is 30. I just used the diagram. I didn't look at the 60. All right, see you all. Welcome. Oh, there was a question about some emails. These are related to the physics. I received 3 emails with the link. 3? Well, you probably received an email that you've inviting you to Canvas. That's the first email. The second email is that you've been added to a group, and the third one is you've been added to a discussion board. So probably like that. But if you can access Canvas, then it's fine. It's all right. I've received all of the emails, but joining groups and stuff, but I've reading with the invitation. Not sure. Oh yes, we sometimes click resend invitation to everyone. So just ignore if you received multiple ones. Okay. As long as you have access. Right. See you.